want to think about this practically. Haley, please put away your phone. And Chiquato, you don't need a computer right now. So please put it away until after. So when we're thinking about a square root, if you think about a square with an area of 16, so if we're asked to take the square root of that square, what it's asking us is what is one of the sides of that square? 4, right? So the reason it would be 4 is because 4 times itself equals 16, right? So essentially what you're asking is that the number that you're taking the square root of, that is the area, and you're asking what is one of the sides of the square with that area, what is it going to be equal to, right? So the reason why we are able to take out, so in this example, we have 4 times 4, right? 16 can be broken into 4 times 4. And the reason why we are able to take out only one of the 4s is because we're trying to see what two numbers, when multiplied, equals the area under the square root, right? So we're trying to see 4 times 4 equals 16. So the reason why when we take the square root of 16 and the answer is 4 is because 4 times itself equals the area of 16, or one of the sides is equal to 4. Okay. Okay, so let's try an example together. So let's just say we have, 100. Okay, so for 100, what numbers multiply into 100? 25, okay. So 25 times what equals 100? 1. Okay, that was very interesting. So you have 25 times 4, and can these numbers be broken down even more? Okay, so what can 25 be broken into? Right, so 5 times 5, right? And what can 4 be broken into? Right, 2 times 2. So you can see here that there are 2 pairs, right? There's a pair of 5s, and there's a pair of 2s. So in the case that you have a pair of 5s and a pair of 2s, both the 5 and the 2 go on the outside, and you get 5 times 2, which equals 10. So when I get an answer of 10, again, what I'm asking and what my original question was, if I have a square with an area of 100, what is one of the sides equal to? Right? That's essentially the original question. What is the square root of 100? It's asking us, what is one of the sides of that square equal to? Well, if our answer is 10, that means we know that all the sides of that square are equal to 10, because 10 times 10 equals 100. Does anyone have any questions at this point? Question?
We already know that square root of 100 is 10. Do we still have to do additional work to prove that we know it's 10?
No, but the reason why I'm showing you this is because now we're going to get to interesting problems. Okay, so these are all problems where, they're called perfect squares because they have you can actually just find two numbers that you already know, and then you could just go ahead and solve it. Okay, so you are going to get numbers where they're not as easy. Something like if you had the square root of 20, then you want to think about, so the first thing you want to think about is what numbers go into 20? 10. Okay, so I'm going to take a couple at a time. I have 10, and I'm going to say 10 times 2 equals 20. And then what else? Can this be broken down even more?
Yes.
5 times 2 times 2.
5 times 2 times 2. So at this point, I want to look for any pairs of numbers that I'm multiplying. So once I get to the prime factors, or a number where I cannot divide anymore, then I want to look for any pairs that have. So what pairs of numbers do I have here? 2, right? So there are 2 2s, so I can circle them, and again, only one of them gets to leave, the other one, in a sense, disappears, and my answer is 2 root 5. My answer is just 2 root 5. So you might be asking yourself, what the heck does this mean? Well, we have the same idea here, which is that, well, if I have a square with an area of 20, one of the sides is equal to 2 root 5, and the other side of the square is also equal to 2 root 5. And if you're like, what the heck does root 5 mean? Well, if you take the root of 5, the exact value is actually equal to 2.23606
I'm trying to get a light with that stuff.
7977.
It's like dying all over my hand, so I'm trying to get it off, and then this thing got stuck. And
You could have just used hand sanitizer.
But the hand sanitizer is empty.
There's some over here.
Where? Where? Right in front of you.
Right there. Literally drop it right there. So that you
Oh, why is that? Oh my god. Yeah.
throw these glasses. You got that negative focus.
Okay, does anyone have any questions about this? Okay, so we're almost done. There's one last part we want to talk about. That's a great question, and that's a great segue. So, okay, we're almost done, so let's pay attention just for a couple more minutes. Okay, so now the question is, what happens when we have a cube root? A cube root meaning to the third power. Okay, so the other one, which we call a square root, has to do with a square. So what do you think a cube root has to do with?
A cube.
A cube, perfect.
So smart.
Okay, so when we're doing a cube root, what it's saying is that if you have a volume of 8, what is one of the sides equal to? Or essentially, if I multiply a number by itself 3 times, how do I get to the number under the cube root? And no, it is not 3. So the number would be 2 times 2 times 2, and because we have 3 of the same thing, then our answer would be 2. So what we're trying to answer here is that if the sides of the cube were all equal to 2, then the length or the volume of the cube would be equal to 8. So this may be essential when you're trying to make boxes with certain dimensions. If you wanted to have a certain volume, but you want it to be a cube, then you can figure out what the dimension should be for each side to hold a certain volume. Does that make sense? Okay, so let's go ahead and do another one, which is similar. So we have, let's say that we have the cube roots of 48. Okay, so the cube root of 48, what divides into the cube root of 48? 6 and 8. We have 6 and 8. Okay, and then what divides? Can we break up 6 and 8 even more? Joshua?
3 and 4.
Do you want to be a little bit more specific?
Oh, 2 times 2 times 2, 2 times 2 times 2 times 2 times 2. That's 2 times 2 times 2 times 2. I don't know.
Okay, so let's focus on one part at a time. What divides into 6?
3,
And?
2.
So we can break that into 2 times 3. And then what can 8 be broken up into?
4 and 2.
Or?
2. 4.
I'm very smart.
Or?
2.
Or 2 times 2 times 2.
Oh, yeah.
I'm very smart.
Okay, so again, when you're looking for the cube root, you want to look for 3 numbers that are multiplying each other that are exactly the same. So we have 3 here, so they leave, and you get 2 root 2 times 3, or 2 cube root 3 of 2 times 3, which you can just simplify as 2 cube root of 6. Okay. So before I let you go and do your homework, there is some rules that I want you to remember. And let's just to go over. They're just refreshers. Okay, so rule 1, how do we know something is divisible by 2?
If it's even.
If it's even. How do we know if something is divisible by 3?
If it's odd. And or even. Or multiple by 3. There you go.
Can you move it up a little?
Like that?
Yeah. Material is
So we know it's divisible by 3 if you add up all the digits together and it's divisible by 3, then it is divisible by 3. So as an example, 1, 6, and 2, if you add up the digits together, so 162, that would be 9. And so that's divisible by 3 because you can add up the digits together and it's a number divisible by 3. How do we know if something's divisible by 4?
That's the answer.
There's a 4, 2, 6, and 8.
Not necessarily.
Oh, close.
So if you can divide it by 2, you can divide it by 2, and if you can divide it by 2 again, then it's divisible by 4. Okay? Oops. Okay, how do we know it's divisible by 5?
I don't know.
Put 5 in a 0. Or 1. No, well, basically it's just like a 5, and then like, okay, look.
Put it in.
No, look, it's like, if it's a 7 and it ends into a 5 words, yeah. Thank you, sir. Thank you. Thank you.
Use 4 feet to think that.
See, that is exactly what I meant.
Small.
I take credit.
What?
Okay, how do we know if it's divisible by 6?
It ends in the 6 or a 2 or an 8.
69.
Yes.
Exactly.
That's not even divisible by 6.
But it's always the answer.
No, that's not right.
Yes, it is.
I'm not the one answering it.
But I can't. Anything is possible to try.
Oh, wait. 69. Okay, hear me out. It's like, so 3 and 3 again. Same thing with the 4. it's like, no, I'm sorry. There's three, yeah.
Okay, so we know it's divisible by 6 if it fulfills. Wow. If it's even, and if you add up the digits and it's divisible by 3. So we know that if it fulfills both of these at the same time, then it's divisible by 6. So that makes sense because 6 is a multiple of 2 and 3. So it has to fulfill both the rules of 2 and of 3.
What's the rule of 3 again?
If you add up the digits together and they're divisible by 3, then it's divisible by 3. So as an example, if we were given 162, you would add up 1 plus 6 plus 2, and it's divisible by, it's equal to 9, which is divisible by 3, so that's the rule.
But like, that's like the one thing your teacher told you not to do in kindergarten.
What?
Don't add like.
So that's not true because your teacher wouldn't be asking you to find out multiples of 3. That's a totally different issue.
No, but like I think that was like the number 11.
She's probably just asking you not to add those numbers together in general, but we're asking, is this number divisible by 3? That's a very different question.
Oh, okay. I'm very smart.
Yeah, sure.
Okay, we're going to skip 7, 8, and 9.
Because we don't care about those.
And for 10, if it ends in a 0, it is divisible by 10.
If it ends in a zero, it's divisible by 10.
Yes.
Interesting.
Okay, you guys can work. Go ahead and start working.
Wait, what happens when it's like,